Okay, I was originally gonna do another problem, but before recording the video for that problem, I came across this problem, and this problem gave me a lot of trouble. Why? Because it has to do with trigonometry, and well, at least the solution that I read had to do with trigonometry, and in fact, all the solutions that I read had to do with trigonometry. But if you can figure out an alternate solution that does not involve trigonometry at all, please tell me about it in the comments. I would really appreciate it because I'm basically gonna walk through a trigonometry based solution, but I'm still really curious to see whether there's another approach that you can take for this problem because it really screwed me up because I'm not really used to trigonometry problems, if I'm being honest, in Olympiads and stuff like that. So that is something that I do gotta work on, which is partly why I'm making this video. So let's dive into this problem. So it reads, in the trapezoid ABCD with bases AB and CD, M is the midpoint of side DA, and if BC is equal to A, MC is equal to B, and angle MCB is equal to 150 degrees, what is the area of trapezoid ABCD as a function of A and B? And what it means by a function of A and B is basically express it in terms of A and B. So let's break down to kind of draw this part by part. So a trapezoid ABCD with bases AB and CD. Let's draw something like that. Oh, okay. It's gonna be a pretty rough trapezoid. Should look something like this. Not the best drawing, but it'll do. And it has bases A, B, C, D. So let's draw this A, B, and then C over here, and a D. Then M is the midpoint of side DA, so we're gonna draw M here, and we're gonna mark DM and MA as equal because they are. And then BC is gonna be equal to A, so this whole thing is going to be equal to A. And MC is going to be equal to B. We're just going to mark it as B. And angle MCB is equal to 150 degrees. And now we got to find the area of ABCD as a function of A and B. First things first, let's draw a midline of the trapezoid, and what I mean by that is a line that connects the two legs of the trapezoid, in this case ABCD, the two legs, AD and BC. So M is the midpoint of AD, and we're gonna get the midpoint of BC, and let's name it H. Actually, no, let's change that because I'll confuse us with the height. So let's make it E. Sure, E. And then CE is going to be equal to EB. And by definition, ME is going to be parallel to AB and DC. So we know that, right? Now, basically, what we're going to want to do, actually, I'm going to change to blue marker to write down our notes while kind of keeping the graph clean. What we're going to do is we're going to define, right, what the area of the trapezoid ABCD is in general. We know that by definition, the area of a trapezoid, in this case, area of ABCD, is going to be equal to AB plus CD over 2 times H. And we're going to define H as basically this little height from C. I mean, it'll be the same thing if we draw it from here. But point is that it's the height of the trapezoid times AB plus CD over 2. And now let us define ME. because by definition, ME does have a length that we can define in terms of AB and CD, which is actually ME is equal to AB plus CD over 2 because it is the midline. So it's going to be equal to AB plus CD divided by 2. And so the area of ABCD in terms of that line ME is just going to be equal to the area of ABCD is then just ME times H. So we already simplified this down a bit, but we still haven't used, the variables A and B. So let's get to that. Let's quickly define this line and this line right here, because we know that this whole segment BC is just A, and E is the midpoint of BC. So then these two lines, CE and EB, are going to be equal to A over 2. So let's kind of erase this to simplify this a little bit. And now we can get the area of triangle CME. We want that area because we actually have two definitions for that area that will help us kind of clean things up a lot and basically lead us to a solution of the problem. So let's find the area of triangle CME, which is base times height over 2, and the base being ME and the height being H over 2, because this whole thing is H, and since ME is the midline of the trapezoid, we're only going to use this part of H, which is just half of H, because this is half of DA, this is half of CB, so then this is half of the height. So area of CME is equal to ME times H over 2 times 1/2, which is then equal to ME times H over 4. And you can already see how this is starting to connect a little bit with the area of ABC. I meant to draw 4 here, but you can kind of see how this is starting to connect a little bit with the area of ABCD. You can see how this triangle's area is going to be 1/4 of the area of the whole trapezoid. It's just a quarter. And now this is where the trigonometry starts to settle in a little bit, because using trigonometry, we can figure out the area of triangle MCE or CME with just this side, this angle, and this side. And the formula is basically the two sides. Let's write here, area of CME. The formula for this in trigonometry is one side times the other side over 2. In this case, one side is B, and the other side, which is A over 2, because we're talking about the small triangle here, over 2 times the sine of the angle that lies between these two sides, which in this case is 150. So it's going to be sine of 150. And here is basically the part where you need to know about trigonometry a little bit, which is what screwed me over, because I do have that weakness that I barely know about trigonometry. And the sine of 90 degrees is 1, and the sine of 30 degrees is 0.5, and the sine of 150 degrees is also 0.5. It's just kind of those things that you need to know and memorize. So since sine of 150 is just 0.5 or 1/2, this whole thing is going to simplify, and this is, then just B times A over 4. It's just going to be B times A over 4 times 1/2 which is then equal to b times a over 8. And now we have these two areas of CME, which are just ME times AH over 4, and then B times A over 8. So we have that ME times H over 4 is equal to AB over 8. And we also know that the area of ABCD is ME times H. So we actually have the area here. All we have to do to isolate for this area is to multiply both sides by 4. And that basically simplifies to ME times H being equal to AB over 8 times 4, which you can cross, and then you'll be left with AB over 2. And that is basically the answer. So, yeah, I hope you understood. This definitely wasn't my best explanation because I'm not that versed in the topic, but I still tried to explain it to the best of my abilities. I hope you understood. If you have any doubts, any questions, and again, any alternate solutions, please leave them down in the comments, and I will try to respond and answer any question that you might have. Yeah, that's basically about it. Thanks for watching. I hope you enjoyed and learned something new. Bye bye.